ahora con ustedes les presento al doctor Amit Vasavada. Es el Senior Vice President y director de Research and Development de Marine Bioinnovations. Amit Vasavada estuvo en Puerto Rico hace como 2 años, año y medio. Yo lo recibí y fuimos a visitar la estación experimental de Juana Díaz. Marrón tiene mucha interés en la biodiversidad de Puerto Rico y también en conectar con el ecosistema de investigadores en Puerto Rico. Los productos de Marine Bioinnovations se consiguen en Puerto Rico y de hecho vamos a tener a Peter Vivoni de Agro más tarde, que es el distribuidor de esta línea de productos, para que nos hable del mercado. Amit, welcome to our virtual meetup. We've been talking for a while, and finally we make this happen. I'm really happy that you are with us today, and please go ahead with your presentation.
Very good. Yes, very good. Thank you. Yeah, thank you very much for inviting me, and it's a real pleasure to speak to you all about our products. I'll start sharing my screen very soon. Well, I took this picture a while ago, almost 15 years ago, when I was up there, and I started thinking about the agriculture. At the time, I was not with Marine Bio, but I was thinking about agriculture as it was practiced way up there in the Andes, down in Peru. And they had done a remarkable job. And since then, obviously, as we heard today, we have agriculture that runs to a commercial level, and we have really a big need to feed the world with increasing population. So what I decided to do was give you a little flavor of the products that we have or what we do in our company. And the title of my talk is Biological Pesticides, Stimulants, and Fertilizers, a solution for environmental sustainability in agriculture. And as you heard, I've been quite familiar with Puerto Rico. First time ever, I think Puerto Rico was in early 2000s to visit a friend of mine, the professor in La Paz, and the Institute of Marine Biology. And that was to actually look for biodiversity from ocean for different application. In that case, it was enzymes to find for agriculture use or industrial use. Since then, I've been to Puerto Rico several times, and I had the pleasure of meeting Ricardo a couple of years ago, as well as some of the dignitaries in Puerto Rico. And I was very impressed by the excitement around biological products. So my presentation outline will have an overall company overview, the pesticide issues that we face as an industry, and the needs of alternatives, the biologicals, how they're defined, the types of biologicals, and how we discover and develop products. And if I have time, I will talk about a couple of interesting new products that we are working on and final thoughts. We are a public company, so I have to put this legal document here, but we don't have to go through that. It just shows that it is a forward-looking statement, and we have a large number of products with registered trademarks. So the company Marine Bioinnovations is based in Davis, California. I've been there for about 6.5 years now. And the company was started in June of 2006 by Dr. Pam Rohn, here featuring the picture where my pointer is. And then she is a serial entrepreneur, and this was her third company. The previous one was AgroQuest, which was sold to Bayer for $500 million. This is her third company. Since 2006, we have actually discovered and developed 7 commercially available products for biological pest management and plant health. And all of them have gone through EPA registration process. So within short 14 years, we have 7 products and several more in the pipeline. We have about 120 employees, and 34 of them are in research and development, which is what I'm responsible for. The products are, some of the products are being also made at our fermentation facility in Bangor, Michigan. And currently we sell products in North America, Latin America, Africa, and East. And again, we are a public company. So what we do is farmer-focused agriculture solutions. We start with sustainable sourcing. That could be from nature, soil, water, forests, as well as some of the microbes derived from insects that can be used to use innovative technology of screening if there are microbes, as well as plant insects. Get some patents on them to make sure that we have coverage and authority to practice this kind of research, as well as to the field testing. In terms of screening, we have screened hundreds and thousands of microorganisms and have come up with 18,000 microorganisms in our library, which have shown activity. I'll talk about that later. And we also screened 350 plant extracts, which showed activity against various pests. So what we have come up with is 3 sets of products. First one is a pest management, and these are the true biopesticides, which protect plants against insects and various fungal diseases, nematode diseases, etc. And also they prevent environmental damage by substituting for some of the chemical products that are being used. The second group is crop health set of products, which basically are not biological pesticides, but they work with the plant to make plant health better, and they're also called biostimulants. And the third one is crop nutrition products, which are primarily nutrition only, or they provide the enhanced uptake of nutrients from the soil using specialty microorganisms. I don't have to go too much into detail, but as we all know, there are lots of pesticide issues around the world, and the amount of product chemical pesticide being used on the left side, China leads with almost 1,800 millions of kilograms of pesticide, followed by the United States, Argentina, and so on and so forth. But that's not the only thing. We know that these chemicals are needed to feed the world. However, as we have learned, more and more pesticides are causing issues. For example, neonics, they have primary suspect in the disappearance of the bee colonies, which are good big pollinators. We have paraquat, what's linked to Parkinson's disease, and the list goes on and on. So we know that chemical pesticides do have a role in causing environmental disasters. However, we can't live without them, not yet completely. In addition to that, we have climate change. Consumers are becoming more and more weary of pesticide residues. We're seeing pest and weed resistance in the marketplace because of the overuse. And then pesticides also, they drift when they're applied on a windy day. So there are lots of different things that play a role in causing the issues that we're facing right now. And finally, because of those issues, we have lawsuits happening. So there are so many different pressures and reasons why we need some alternatives. So why biologicals important? So as I mentioned, there's a fertilizer overuse. So can biostimulants and biofertilizers help out by reducing the phosphated nitrogen runoff, which is used in excess, causing algae bloom and anoxic zones? Can pesticide overuse be prevented by using biopesticides, either standalone or in an integrated pest management program, which is where biopesticides or biostimulants are combined with a traditional chemical to reduce the overall environmental footprint of the chemicals, so that we can help the beneficial pollinators, prevent the resistance by insects and the weeds. And finally, the soil health has also become a very, very important aspect of biologicals, which is actually helping rebuild the microbiome in soil to improve soil fertility and prevention of accumulation of metal and toxic compounds. So these are the reasons why biologicals can play a major role. And eventually, a number of benefits, of course, are great. So we can manage the resistance, even farmers and the harvesters and the labor force in the field can be provided better health in their work, and eventually residue management. All in all, to give better quality of food, improve productivity, and minimizing the impact on the environment. So where we started at MBI, Marine Innovations, is a large number of samples from various soils, the water, forestry, etc., and various unique habitats. And we actually isolated a large number of microbes, and once you take a sample, this is what it looks like, which is composed of large number of different colonies and microbes that come from the environment, but not all of them may be useful. So we actually verified each and every little colony of microbes, separated them out, grew them out, and tested each and every extract to see if they have any activity. And in the meantime, we were also classifying the organisms, and we found that we have approximately 30% each of bacteria, fungi, and actinomycetes. So once we have the purified cultures, we subjected them to 7 different biological assays that we established in the lab. We had insecticide assay, fungicide assay, herbicide assay, nematicide assay, algicide assay, bactericide, and biostimulants. So all of these were done in a very medium throughput manner to come up with the potential microbes and or plant extracts that could be used in various areas. We used some of the very specific microbes for plants as model systems, and we finally came up with a list of hits of microbes, which included either herbicide hits or insecticide, fungicide, and so on and so forth. In the second column, you see the number of total hits. So when we screened a large number of microbes, this is what we came up with. So we have approximately 2,500 or so potential products that came out of our collection. And this was done in the early 2000s, or mid-2000s. So, and with the new genomics technologies, we can probably go back and find more hits out of this particular system. You can see that at the bottom, we have about 8% of our hits within plant health, and we already have 108 out of 1,400 microbes. So if you were to go all the way up to 18,000 organisms, we could potentially have a couple thousand plant health products as well. But not all these hits can lead to the product. So what we have relied on is the chemistry that is produced by these microorganisms. And this is the chemistry with the standard metabolism of the culture. And when they grow under certain conditions, they make very interesting compounds as shown here. And we actually identify these natural compounds and see whether they have any effect on various pests. And over the years, we have identified very exciting molecules, and which are normally not found in nature, are synthesized. And if you were able to synthesize, it would be very expensive. So microbes have really created some variety of chemistries, and we take into account the combination of biology and chemistry to make our products. We developed farmer-friendly formulations out of that, and scale the fermentations up to almost 100,000 liter scale, conduct the field trials, and finally we use all that data to develop a dossier for the regulatory submission. So we go through the development pathway from screening, which I talked about, developing the processes, learn about the chemistry, the testing from lab all the way up to the field in various geographies and various soil types. And then in the meantime, we scale up the processes, submit our dossier for EP approval, and eventually we get the approval. Now, in the meantime, we are ready to do a second generation development as well. Now, EP approval is very important, and what I would like to say here is that not only it's a very restricted process area where we have to supply specific biological processes, various formulations that we have, what is the active ingredient, and how do you characterize and how do you track it in nature, how does it work, mode of action, and then the biological safety. This is one of the most important aspects and expensive aspects of developing a biopesticide. We need to show that it's not toxic to mammals, either on the skin or oral. It's not toxic to aquatic species such as fish. It degrades in soil, and it does not affect the beneficial insects. These are very, very important aspects of our products and any biological products. Along with field data, we have a very strong case for submission. So based on that, we have come up with a large number of products that I mentioned, and I'll very quickly describe some of these. So this the one at the 12 o'clock position here, Stargus. Stargus is a Bacillus amylolactofaciens product. It's an antifungal or fungicide. It works on white mold, arthritis, downy mildew, and it is a liquid product. Grandivo is a fermented product and killed microorganism. So the microorganism does not need to survive in the field. And it is a product by Chromobacterium, and it kills a variety of insects. And it has novel chemistry and mode of action. It's 3 different active compounds, and they work together to make its to get its activity. Venerate and Megastine are produced by an organism called Burkholderia species, Rhinogensis, and it's one organism that's producing 2 different compounds, sets of compounds, and 2 different products. Venerate is an insecticide, and Megastine is a nematicide. Both of them are very powerful products which we sell in the market. And then on the other side, we have Regalia, which is a fungicide and plant health product that came from giant knotweed, so it's a plant extract. Equinox is a muscle control product, which is not a main agricultural product, but it is made by microorganisms. It's fermented and it's killed. So you can see that the common theme here is that we have 2 insecticides, nematicide, and this Equinox muscle product. They are all killed microorganisms as opposed to live microorganisms. So over the years, we have added a few more products. So we have the pest management area I just talked about. For plant health, we have added 2 more products this year, Pacesetter and Emergent, based on plant extracts. And for crop nutrition, we bought a company in Finland which sells plant-based products for seed treatment and foliar fertilizing. And when farmers have been using these products, they find that organic farmers can use these biopesticide rotations and tank mixes. There is no residue for export, and conventional farmers also can use them in tank mixes. Our products can actually work with the local farmers. So we heard that farmers want results very fast, and a lot of times combination of our products with the traditional products can help the results very fast. And at the end of the day, farmers are always thinking about what is the yield on their expenses. So for strawberries, they can get 9 times the return. For corn or wheat, they can get 4 times, 3 times, etc. For potatoes, we have an excellent product for potatoes, sweet potatoes, yams, etc. And then for almonds, which are very high value products, for 20 times the return on investment. So we not only discovered and developed and sold, but farmers have been using them very successfully. Regalia fungicide, I will not go too much into detail, but it is a product that improves root hair growth, chlorophyll, and then it has 6 different compounds present in the product, and it's available in all over the world, many countries of the world. The mode of action, the way it works, is to induce systemic resistance in the plants themselves, and we have shown that with the gene expression studies in the plant. It also synergizes with chemical fungicides, which is a very important aspect because, as we heard, sometimes the biologicals are more expensive. The farmers would rather use chemicals, traditional chemicals, but they can substitute and or combine to reduce the footprint in the field. Stargus, it's a Bacillus ameliorations, is a dead microbial except for the fact that it produces spores, so spores can actually germinate in the field, but it produces interesting chemistry, lipopeptides, which are working against the fungi. And when used in vineyards, instead of using traditionally copper, grams and grams of copper to prevent the disease, we can use just 4 or 2 of our product, and it reduces the copper overuse in the field. So it's also an approved product. For Grandivo, it is a chromobacterium. It's actually purple fermentation, beautiful purple colored product. And it works against large number of insects, and it's sprayed. Also, it can be used as a granule. And that also has 3 to 4 different types of chemistries produced during the fermentation. And the organism itself is dead microbial. So we don't need to worry about spreading into the field. It does not have any effect on pollinators and beneficiaries. Venerate is a Burkholderia species that works on a large number of different insects, shown on the right side, chewing and sucking insects. And also we have a product, a similar sister product, made by the same microorganism in fermentation, which is nematicide as well, and it's working really well. So in tropical fruit diseases, we have a potential for our products. Magistine is a nematicide against bananas, in bananas. For Venerate, you can use it for pineapple, banana, mango, and cabbage. For Grandivo, you can use banana, pineapple, mango, and cabbage. And then Regalia is being tested on banana against Sigatoka control. And we have active work going on as well as results from the past. For cocoa, we have a large number of diseases caused by various fungi and bacteria, and we can use some of our fungicides. Sometimes they're insect vectors that are causing some of these diseases, so Grandivo and Venerate can help as well. So we have a large amount of work going on in tropical countries using our current products. And lastly, I'll talk about one particular area and just a couple of slides on this. So Burkholderia, the same microorganism, that means the insecticide and nematicide, also has an herbicidal compound that's produced, and we have been able to sort those different products into 3 different processes and show that it is a very powerful herbicide. And it is a herbicide that works against one of the most important weeds called palmer amaranth in less than 6 days. Now, obviously, this is a very early stage work. 6 days is still very good for a bioherbicide. You can see that the time of spray all the way up to the end, you can see the plant is completely dead. We know that the compounds that the organism produces, they move through the plant and eventually also, it works against a large number of different weeds, and all the ones in the green are 90+% control, and then so on and so forth. So even though the control is 60s and 70s for some of these weeds, we can imagine improving its efficacy, our product's efficacy against these weeds by combination with other herbicides. So we haven't stopped there. We've used the traditional screening methodology to develop these products and potentially future pipelines. But we have started using genomics information to learn about the microbiome in the soil to make sure that our products don't affect the nutritional quality and destroy the microbes, which are a really important part of the soil, the microflora. So we use that. We use drones to monitor some of the activities of our products to show that, to learn about how our products and doses work in the field. Here on the bottom right, you can see the green areas are good areas of the field where we planted, we had sprayed. The red areas are the control areas where the plants were negatively affected. So we can see that our products are working pretty well. Of course, not as well all across the board, but we can really see using the drone technology. As I mentioned before, we have learned the genomics technologies to understand how our products interact with the plant itself to activate the defense mechanism of the plants. And Regalia and Stargus work that way to help not only mitigate the fungi on the surface, but also make the plant make antifungal responses. We are eventually interested in developing the microbes themselves to make better profit margin and the cost of goods so that we can make large profits. So in summary, we have developed novel bio-based solutions using natural microbe-scale platform and innovative fermentation and formulation processes. We have introduced insecticides, two fungicides, two nematicides, and then some plant cell products. And we don't have to really work as a standalone product. Our products work really well with traditional chemistries as well because farmers like quick results, and we've shown that in some cases actually there is a synergy between our products and the traditional products so that they can get more yield while reducing their chemical environmental footprint. We continue to develop novel solutions for farmers, especially the herbicides. We also have a biofumigant that we're working on instead of methyl bromide, which is used widely in strawberries and some of the high-value crops. We can use biological fumigant, which works really well. And the whole point about having these biologicals is not only help out the farmers with their worries and the consumers with their worries about pesticide residues, but also alleviate the environmental issues caused by pesticides. So with that, I thank you very much for your attention, and I hope that I wasn't going very fast, and I'll be happy to take some questions.